Next, I'd like to talk about layer emitters in Trapcode Particular. This allows you to take any layer in After Effects that is a 3D layer and use it as a particle emitter. I'll use a piece of text here. Now, when we're using text or we are using shape layers in particular, we will need to pre-compose this. This is just a workaround for After Effects. Even if I make this text a 3D layer, it's still going to want to have this text layer be pre-composed. So now I have my text, and let's say I orient this just a little bit and move it. If I go to Particular and set the emitter type to Layer, in the Layer Emitter section, I need to define the layer as my emitter. Now, as soon as I do that, we see just a few particles on there. I'm going to turn up the particles per second to a lot more. Now, you'll find with layer emitters that you'll need to really turn up the particles per second count a little bit higher than you might expect. And this will happen more if you have a lot of blank space inside your composition. Now, I'd like to come back to a point that I made earlier in this series about the difference between where we make particles and what the particles are doing immediately after they're born, which was in the emitter section. So we can say where the particles are born with the layer emitter, but even though this layer emitter is 3D and has sort of a direction, it has X, Y, and Z, the particles are emitting uniformly because that's our default setting. Our direction is set to uniform. If I set this to directional, then the particles will emit in a specific direction with text. Now, to illustrate this next section, I'm going to go to the emitter and rotate this 90 degrees so that the directional emitter is shooting the particles downward. So now I'd like to talk about the different options we have. And one of those considerations that we need to make is what happens if our source emitter changes over time. I'm going to animate this text over time just so that its position and color changes inside this pre-comp over time. So I'll go to the Animate menu here and we'll animate its tracking over time. So I'll set a keyframe for tracking, track this out. Also, I'll go inside here and set 2 of these letters to a different color, and we'll also change those over time. So I'll go to the fill color and animate the fill hue over time. We'll just have it do 1 full revolution. So now if I am using this as a layer emitter, we'll see that the particles tend to follow the source layer emitter. And actually what's happening is that they are instantaneously sampling it and staying with the changes of the layer over time. So if the particle is born at this point in time and is green and the emitter changes to blue, the particle will change with it. Now it is inheriting the particle color from the source layer because our default option here is to use the RGB color of the layer source. But we want to talk about the layer sampling. So the default option is to use still, and this is exactly what it's going to do. The particles will instantaneously inherit changes from the source layer, including if it disappears. So if I go in here and trim this down, let's say I trim this layer just after 3 seconds, and we scrub forward. When the layer disappears, the particles disappear. So let's set this to particle birth time. Now, what we'll see is that the particles inherit properties from the source layer at its time of birth, and it will retain that property over its lifespan. So if it's born at this point in time as a red particle and the source layer changes to a different color, you'll notice that the particles that were red at the beginning are still red. And if I scrub forward in time and our source layer suddenly disappears, our particles are still there because they were born at 3 seconds. So they will continue to live until the end of their lifespan. Our last option is current time. And this is actually more of a legacy thing. You might be wondering what this is. And actually, you'll see little difference between current time and still. But like I mentioned, current time is the old method. This is actually how Particular used to be. So what this layer sampling method does is sample and generate particles on every single point of the layer, even if there's transparency. But if it's transparent, it is generating a transparent particle, so you never really see it. This makes it easy for Particular to generate particles without having to search internally within the image to find where the image is or isn't. It simply generates particles everywhere. Now, this doesn't really cause a whole lot of problems until you use something called the aux system. So this is getting ahead of ourselves, but the aux system turns our main particles, and these are our main particles right here. This turns our main particles into particle emitters themselves. So any of these particles in here will become particle emitters as I turn on the aux system. Now, if I am generating invisible particles, the aux system will generate particles from all of those invisible particles. The aux system does not properly inherit that transparency from those particles, and it simply becomes a very inefficient way of sampling the layer. So in short, the current time setting is more of a legacy thing. You won't see much of a difference, but you will run into problems if you're using the aux system. This is why the new default is the still option, but particle birth time is also very, very useful if you'd like to make changes to your layer source over time. Now, there's lots of other options in here to have the properties of the source layer drive different properties of your particles. You can have the lightness drive the size of your particles. So I've got white over here, which is going to drive larger particles, and then the area where I've got darker colors or darker lightness, we have smaller particles. Or we can have things like the lightness drive the velocity. Now, there's some other options in here that get into very detailed control, such as RGB driving things like size, velocity, rotation, and color, or XYZ velocity. This is essentially working as a motion vector where red corresponds to X velocity, G corresponds to Y velocity, and B corresponds to Z velocity. There are separate tutorials that go into this about generating motion vectors from video, dropping that into a layer emitter, and then using the motion vectors to drive the velocity of your particles. If you look up motion vectors with Trapcode Particular, you should find tutorials that cover all about using motion vectors from your video to map RGB to XYZ velocity. So let's apply what we've learned in a practical example. And what we'll be doing is taking an image, in this case text, and have it dissolve away to particles. This is something that just about every motion designer has to do at some point in their career, and this is very possible in Particular. Now, I'll keep this composition open, and we'll come back to it a couple times just to show how the layers are organized and how they are used. It's not very complicated, but there's some specific setup in here that we'll be doing. But first, let's just jump in and create our composition. So this will be, I'll create a layer for Particular and apply Particular. I'll go to my source composition and copy the text layer that I used. I'm going to make sure to remove any effects on here just so that we construct everything from scratch. But this layer is just a pre-comp that has some text in it. It's using After Effects text. It's in a composition that is 3D, because remember, we need our layer emitters to be 3D. Next, I'll go to the emitter type, set this to be a layer emitter, and then the layer emitter section, I'll define that layer right here to be layer number 2, my text. So we can immediately see that we have particles coming off of the text area. I'm going to increase the particles quite a bit to, let's see, that's 100,000. Now, I keep saying that we haven't covered some of these sections in detail and that I'll cover them later, and I'm going to say that again. Now, there are other ways to do this. I could structure this with directional emitters, but in this case, I really just want wind. I want wind blowing my particles to the right. Being that I have wind available to me in the physics section under air, I'm simply going to use that. So I'll turn up my wind, let's say to 250, and now this is pushing particles to the right as they emit from the text. Now I'm going to do one more thing that will really add to the aesthetic of this. In that same physics section under air, there's this thing called turbulence, and I'll explain all about turbulence in a later lesson. I'm going to turn this effect position up to 100. And all this is doing is applying a turbulence field to the particles in space, and it gives it a bit more organic of a feeling. I'm also going to go to the particle section and just have these scale over time. So I have the basic look of the particle, the basic motion of the particle. It's scaling out over time. So all we need to do is handle how we get the text to dissolve away and have the particles dissolve away with it. And this is actually quite simple. So there's two things we need to do. We're going to have two different layers, and I mentioned I'm going to come back and show you this in the original comp. We have one layer that we are seeing, and this layer simply dissolves away like this. This layer is visible. We'll have another layer that's essentially a duplicate of that source, but instead of having that linear wipe, it is going to have a thin strip that's visible like this. And this thin strip is what is going to be the layer emitter for our particles. So let me add the linear wipe to this text first. I'll go to Effect Transition and apply linear wipe. And let's say at the, well, maybe 2-second mark, I'll set a keyframe for the transition completion. And at 4 seconds, we'll set this to 100. And this is going the wrong way, so I'll turn the wipe angle to -90 instead of +90. So it simply wipes away. And we'll put some feather on this as well. So that's pretty straightforward. So I need a second layer that looks just like this, but has that thin strip available. So I'll duplicate this. And instead of using a linear wipe, I'm going to use a mask. I have my keyframes down here for reference. So I need to have that thin strip animate at the same rate as the linear wipe. So I'll go to my rectangle tool here and draw a basic rectangle over here to the right. And we'll animate this in the same time as this linear wipe. So I'll hit M to show my mask path. And at the end here, I'll move the mask to the other side. So I'll double click on one of those vertices. And let's move it over to the other side. In theory, these should be animating just about at the same rate. Just as a temporary reference, I'll go to Effect Generate Fill. And I'll fill this strip with a color so we can see what's going on with it. That timing looks just about right to me. We also need some feathering on that. So I'll go to the mask feathering by hitting F, and we'll feather out the mask. So in particular, I just need to change the layer that I'm using as my emitter. So I'll go to my layer emitter, and we're going to use text 2. So let me switch this to text 2. I don't need to see this layer that I'm using as the source. I just need it there for generating particles. What we're interested in seeing is the main text layer that dissolves away. It still hasn't changed, and the reason is, in the layer emitter section, we have a relatively new feature that allows us to define how we look at the source when a plugin, such as Particular, looks at another layer as its source. For years and years, when we did this with plugins, it always would look at the unaffected source, so it would ignore effects or masks. But in this case, we have masks applied to that source, and we want that source to see the masks. So in our layer section here, I'm going to change this from looking at the unaffected source to looking at the source with masks applied. So now as I scrub forward, we're going to see that as the bottom layer starts to fade out, the particles are emitting along that strip of text. The reason it's not using the red from the source is because the red is an effect, and we are only looking at the mask of the source and not the effects and mask. And that's just about it. From here, it's just finessing timing and fiddling with settings until it looks good. I might take these two linear wipe keyframes and shift them so that they overlap a little bit more with the particles. We can probably lower the lifespan of the particle a little bit, maybe randomize the lifespan a bit. And I'm also going to lower the particle size and randomize that as well. So to control the timing of this, we really just have two sets of keyframes, and if I would like it to go slower, I can just drag the first two keyframes out to have the animation take a little bit longer. Lastly, I think I need to raise the particle count even more. I'm actually going to set this to now 500,000 particles per second. And we get that nice sort of dense feeling with the particles, and it's also doing a better job blending in with that feathered area of the text. So in this lesson, we've covered all the basics of the emitter and then covered some more practical examples by using layer emitters as a method to turn an image into particles. Next, we still have another cool feature to cover, which is OBJ emitters. My name's Harry Frank. We'll see you in the next lesson.